Hello, this is Mr. Best. Welcome to questions 81 to 86 on Chapter 4. We're going to solve the following systems of equation using any method, and we're going to check our solution if possible. So let's go ahead and get started on Part A. We have negative 2x plus 3y equals 1, and 2x plus 6y is equal to 2. So it looks like because all the x's and y's are on one side, and the constant is on the other, this one's ready for elimination. We can add the two equations, and we don't even have to change anything because the x's will eliminate, the negative 2x plus 2x. So we add the 3y and the 6y, and the 1 and 2, divide by 9, and make sure when you divide by 9 it is 3/9 or it reduces to 1/3. Now you can take this and plug it back in. I'm going to plug it back into the second equation here. And I get 2x plus 2 is equal to 2, so 6 times 1/3 is 6/3, which reduces to 2. Subtract 2 to both sides. You get 2x equals 0, divide by 2, and x is equal to 0. So our solution is 0, 1/3. We want to check our solution, so we're going to plug the x equals 0 and y equals 1/3 back into the equations and check. And there are the checks, and once again you can see that it does work, so we are good to go on A. Now let's move on to question B. B is set up for substitution. You have really two options. You can take this expression and plug it in for this y, or because the second equation, x is equal to, you could take this expression and plug it in for x. Either way, it'll work, so I'll just do the last one I just did there. So I'm going to rewrite the first equation, y equals 1/3. The x is going to be replaced by negative 3y, and then plus 4. So 1/3 times negative 3 is negative 1, so negative 1y plus 4. If I add y to the other side, that's 2y equals 4, divide by 2, and y is equal to 4. So now we'll plug that back into the equation x equals. So x equals negative 3 times y, which is going to be replaced with a 2. So it looks like our solution is x equals negative 6. So negative 6, 2 would be our solution, what we believe to be our solution. And then once again, we'll check these by plugging them back in. And so once again, there's the check. I plugged it back into both equations, and you can see that it satisfies both of them. So negative 6, 2 is the solution to question B. Question C, 3x minus y equals 7, and y equals 3x minus 2. So this is set up for substitution. So I'm going to take that expression, 3x minus 2, and I'm going to substitute it back in for this y value in the other equation. So I get 3x minus, and since it's minus the quantity, I need to make sure I put parentheses here. 3x minus 2 equals 7. Distribute the negative. So 3x minus 3x plus 2 is equal to 7. The x's cancel out, and I'm left with a statement that is not true. 2 is not equal to 7, so therefore we have no solution, which means our lines are parallel. And it says check each solution if possible. I'm still going to check this one, but what I'm going to do is I'm going to take the first equation, 3x minus y is equal to 7, and I'm going to put it into slope-intercept form so that we can see that the lines are parallel to each other. And this is a way that you can check without plugging the numbers back in when you get one of those special solutions. So we get negative y equals negative 3x plus 7 divided by negative 1. So y is equal to positive 3x minus 7. And if you compare that to the second equation, y equals 3x minus 2, think about this. Their slopes are the same, so therefore that's why they do not intersect, but their y-intercepts are different. The one on top here is negative 7 and negative 2 on the bottom, so therefore you're going to have the same slope, but they're going to be going through different y-intercepts. So therefore that is a way to check, and our answer of no solution makes sense. And then I'm going to do question D over here on the bottom left. X plus 2y equals 1, 3x plus 5y equals 8. This is set up for elimination. Let's go ahead and eliminate the x by multiplying the top equation by negative 3. So this is my new equation here. So that replaces the x plus 2y equals 1 by multiplying by negative 3. I chose to multiply by negative 3 because then that will give me coefficients of negative 3x and 3x. So now I can use elimination by adding the two equations. I get negative y equals 5 divided by negative 1, and I get y equals negative 5. So I can take that. I'm going to plug that back into the first original equations, x plus 2y. So x plus 2 times negative 5 is equal to 1. X minus 10 equals 1. Add 10 to the other side, and you get x equals 11. So our solution is 11 comma negative 5. And then I will go ahead and check this one as well. And there is the check, plugging in x equals 11 and negative 5 into both original equations. Once again, make sure you go back to the two original equations and plug them in, and you can see once again that that is the correct solution. Question 82, the math club is baking pies for a bake sale. The fruit pie recipe calls for twice as many peaches as nectarines. If it takes a total of 168 pieces of fruit for all of the pies, how many nectarines are needed? So we need to set everything up. What are our variables? If we have 1 or 2, we still need to write let statements. So let's start off by, it does want to know how many nectarines are needed, so let's let n equal the number of nectarines. Okay. We also have peaches that are involved, so we can also let p equal the number of peaches. All right. Let's go back to the beginning. We got a fruit pie recipe calls for twice as many peaches as nectarines. Twice as many peaches as nectarines. So that means that we need to have 2 times n would be equal to the number of peaches, because you have twice as many peaches. So twice as many, so you have more peaches than you do nectarines. So 2 times n is equal to p. You could have also written that as half the number of peaches is equal to nectarines. So it could have also been written this way as well. So either one of those would have been fine. Then we also have, it takes a total of 168 pieces of fruit for all of the pies. So a total, so we need to take the number of nectarines plus the number of peaches, and then that will give us a total of 168. So now we can solve this system using any method that we want. It's set up for substitution. We can substitute 2n for the number of peaches, so n plus 2n is equal to 168. That gives us 3n is equal to 168. Divide both sides by 3, and we get 56 nectarines. Now, we could solve for the number of peaches as well by multiplying by 2, but it only wants to know how many nectarines are needed. So we can also stop at this point and just answer the question. And so make sure you answer the questions. We need 56 nectarines for the fruit pie recipe. Question 83, Candace is solving this system. 2x minus 1 equals 3y. 5 times 2x minus 1 plus y equals 32. She notices that each equation contains the expression 2x minus 1. Can she substitute 3y for 2x minus 1y, or why not? So these, let me go back there. 2x minus 1 and 3y are equivalent. That's basically like 5 $1 bills and one $5 bill are equivalent. They look different, but they're exactly the same, even though the variable itself is not solved for. So can she substitute 3y in for 2x minus 1? Well, as long as they're equivalent, then she can. And so they are equivalent. So if you go into the second equation, right here there's a 2x minus 1. All right. So can she replace that with the expression 3y? As long as they are equivalent, that would make sense. And since the equation above says they are equivalent, then yes, she can substitute in because the expressions are equal. Now it wants us to substitute 3y for 2x minus 1 in the second equation to create one equation with one variable and then solve for x and y. So we're going to go ahead and do what Candace had suggested. So now it's on the second equation. It's going to be 5 times, instead of 2x minus 1, we're going to replace it with the 3y plus y equals 32. So we have one equation and one unknown. So 15y plus y equals 32, or 16y equals 32. Divide by 16, and y is equal to 2. Now we can go back to the second or first equation. Actually, it doesn't matter which one, but this would be 2x minus 1 is equal to 3y, or 3 times 2. So now we're going to find x. 2x minus 1 is equal to 6. Add 1 to both sides, and we get x equals 7/2, or 3.5, or 3 1/2. Any of those versions would be fine. So our solution is 7/2, comma 2. And that solves the system of equation from above, the way Candace had suggested in terms of substituting 3y in for 2x minus 1. Question 84, find g of -5 for each function below. So remember, when we have these functions and we want to know what the output is when we have the input, we're just going to plug in what g of what is. In this case, they're asking for g of -5 for all the different functions. So we're just going to plug -5 into all these functions. G of -5 is equal to -5 cubed. It's important that I put the -5 in parentheses because it's -5 times -5 times -5. The negative is included. So that's -125 minus 2, which is equal to -127. So g of -5 is equal to -127. B, do the same thing. G of -5 is equal to 7 plus the square root of 4 minus -5. So it's 4 minus x, x being a -5. Once again, putting that in parentheses will help you not forget the negative sign. So 4 minus -5 is 4 plus 5, and that's 9. So the square root of 9 is 3. And that's equal to 10, so g of -5 is 10. Once again, when you input -5, you get an output of 10. C, g of -5 is equal to the cube root of -5 plus -59. So that's the cube root of -64. So remember, what we're trying to answer on this question is what number times itself 3 times gives you -64, and the answer is -4. -4 times -4 times -4 is -64. So the cube root of -64 is -4. So g of -5 is equal to -4. And then D, we have g of -5 is equal to -4 times the absolute value of -5 minus 1. So -4 times the absolute value of -6. The absolute value of -6 is +6. -4 times +6 is -24. So g of -5 is equal to -24. Tim is buying snacks for the mathletes who love microwave popcorn. When Tim looks at the popcorn selection, he notices many brands and different prices. He wonders if the cost is related to the quality of the popcorn. To answer his question, he purchases a random sample of popcorn bags and records their price. When it is time for the mathletes meeting, he pops each bag in the same microwave, opens each bag, and counts the number of unpopped kernels. So here's the information below. We're going to make a scatter plot on the graph paper and draw the line of best fit, determine the equation of the line of best fit, and then we're going to estimate the number of unpopped kernels in a bag that costs $1.19. So let's first go ahead and graph the scatter plot. We have our price, which is our x-axis, and the unpopped is the y-axis. So we're just going to graph each of these points. I have the x and the y-axis labeled. So the price for this one is $2.30. We're not going to be able to do them exactly, but we can figure out approximately where they go. So I've plotted the 6 points. Now I'm going to make a line through the points that I best can, and then we're going to determine the equation of that line. Alright, now I've drawn in my line of fit. Obviously, they're not all going to be the same, so your equation might be a little bit different than mine. I'm going to choose the points where it intersects nicely here, so let's see what I can find. It looks like right here would be 1, and then that would be at 0.50, comma 30. So I'll choose that point, and then let's look for another one that intersects nicely. Maybe this one right here at, let's see, that'd be $1.25 and 20 unpopped kernels. So those will be the 2 points that I use to determine the equation for the line of best fit. So once again, I'm going to choose those points over here, write those points over here, 0.50 and 30 unpopped, and the other one was 1.25 and 20 unpopped. So let me double check those points that I have. Okay, that looks right. So now we need to find the slope. So we'll do the change of y over the change of x. So we have 10 divided by 0.75. So this is equal to negative 13 1/3. I'm just going to round it to 0.3. And then now we can plug in our point and slope to find what b is. And let's see what we get. I'm going to use the first point, so y would be 30 is equal to negative 13.3 times 0.50 plus b. Add 6.65 to both sides. And that will be equal to b. And if you look at your line, it definitely looks like it intersects somewhere around, definitely between 35 and 40. So looks like we're on the right track here. So let's write our equation. Y is equal to negative 13.3. Makes sense that the slope is negative because the line is decreasing. X, and then plus our y-intercept, or starting value of 36.65. Now, if you chose 2 different points that I didn't have on my line, your equation is not going to be exactly the same, but it should be close to what we have here. So this is part A. The graph and everything in is as well. And then part B, estimate the number of unpopped kernels after cooking in a bag that costs $1.19. So we're going to plug in our cost. Remember, price is our x value. So y is equal to negative 13.3 times the cost, which was, let's see, $1.19 plus 36.65. So plug that in and see what you get for the number of unpopped kernels. So I got y equals negative 15.827 plus the 36.65, which is going to give me 52.477. So we can say around, oh, nope, I messed up. Let me go back. I added the 2 instead of subtracting the 15, so let me fix that. So I actually got 20.823. So right around 21 kernels were unpopped. So let's go ahead and answer the question then. And then there's the answer to the question. Approximately 21 kernels would be unpopped for a bag that costs $1.19. Question 86. This problem is part 2 of the checkpoint for solving linear equations, fractional coefficients. It will be referred to as checkpoint 4. So we're still solving equations, but there's going to be some fractions that are involved in each of these equations. You can also check your answers by referring to the checkpoint 4 materials, but obviously you can check them right here while I do them. So let's start with part A. 1/6 times the variable m minus 3 is equal to negative 5. We first need to add the 3 so we can isolate the variable term. And we get 1/6 m is equal to negative 2. We now need to multiply by 6 over 1, which is the reciprocal of 1/6, to get m is equal to negative 12 over 1, which is just negative 12. So m is equal to negative 12. On B, we have 2/3 x minus 3 is equal to 1/2 x minus 7. So same thing, we want to get the variable term on one side. So we're going to take 2/3 minus 1/2. So 2/3 minus 1/2, you need to find a common denominator. So that would be 4/6 minus 3/6. So that's 1/6. So we have 1/6 x is equal to, well, first minus 3 is equal to negative 7. And then we can add the 3. So we're going to isolate the variable term. And that's negative 4. Same as before, it's 1/6, so we're going to multiply by 6 over 1. And we get x equals negative 4 times 6 is negative 24. And then the last one I'll do on the bottom here, which is C. We have x plus x over 2 minus 4 is equal to x over 4. There's a couple ways to do this. One, we could get rid of the denominators 2 and 4 by multiplying every term by the common denominator. That would look like this if we take every single one of these terms and multiply by 8. So 8 times all 4 terms. That's one possibility, not a bad option as well. The other thing is, when you're looking at this, this is 1x plus 1/2 x minus 4 is equal to 1/4 x. So you do have 3 variable terms that you can get on the same side and combine. So I'm going to go ahead and do it that way. But once again, either way is fine. 1 plus 1/2 is 3/2. So that's 3/2 x. I'm just combining my like terms. I'm going to subtract 3/2 x to the other side to get the x term by itself. That would leave me with negative 4 is equal to, what's 1/4 minus 3/2. So 1/4 minus 3/2. Try that again. So we could find a common denominator by multiplying by 2. So that's 1/4 minus 6/4, which would be negative 5/4. So this is equal to negative 5/4 x. And then we could multiply both sides by 4. Negative 16 is equal to negative 5x. And then finally divide by negative 5. So x is equal to, a negative divided by a negative is a positive. So that's 16/5. Could be rewritten as 3 1/5. Could be rewritten as 3.2. So any of those would be perfectly fine. So x is equal to 16/5. And remember, any of these 3 equations that we just solved, you could always plug back in and check to make sure that you have them correct. And just remember, as a checkpoint here, from this point on, you will be expected to do problems like these correctly and with confidence. So if you're still struggling with any of these 3 problems, please let us know.